initial pressure, initial volume, final pressure, final volume. That's all. Charles' law states that for a fixed mass of gas at constant pressure, the volume V is directly proportional to the temperature when the pressure is constant. V is equal to Kt, where our K is equal to pressure, which is equal to constant. So from here, you can have V over T is equal to K. Okay? And this can give us V1, T1 is equal to V2, T2. And this is an expression for a Boyle's law. Our V1 is initial volume, initial temperature, final volume, final temperature. This volume is measured in centimeter cube. This one is in Kelvin and can be in degrees Celsius, centimeter cube, and the same thing also for temperature. And that's all about Charles' law. Let's consider pressure law. Pressure. The pressure law states that the pressure of a mixed mass of gas is directly proportional to the absolute temperature provided the volume remains constant. The pressure of a fixed mass of gas is directly proportional to temperature. Okay? And what is constant here is the volume. Okay? Let's see. Pressure is equal to Kt. And our K here is the volume, which is equal to constant. Okay? That is P over T is equal to K. Then we can have P1, T1, P2, T2. And that will be a good relation for a pressure law. P1, T1, P2, T2. Here your P, in this case, is your initial pressure, initial temperature, final pressure, final temperature. Okay? And that's what this is all about. Then, finally, we quickly consider general gas law. The three gas law can be combined. That is, Boyle's law, Charles' law, pressure law can be combined into a single law known as general gas law. That is, P, V, over T, everything equal to a constant, which is a constant. When you combine everything together, everything equal to a constant. And from this one, we can have P1, V1 over T1, P2, V2 over T2. Okay? This is what we call a general gas law. And we shall use all the following to solve the following question. Question number 1. The question says a fixed mass of gas occupies a volume, that's V1, which is equal to 20 centimeter cube at a pressure P1, which is equal to 700 millimeter of mercury. Assuming that the temperature remains constant, what will be the volume of the gas? What will be our P2? When we have the P2 to be equal to 750 millimeter of what? Mercury. If you remember the relation for Boyle's law, First law states that a fixed mass of gas at constant pressure, the pressure P is inversely proportional to the following. P is inversely proportional to the following. That's why we have P1, V1, P2, V2. But by the time we have P inversely proportional to the following, we are going to have PV. Okay? So that's how we get this relation. Okay? So now, we have P1, that is 700 times V1, 20. We are looking, this is 750. We are looking for V2. Okay? And V2 will be equal to 700 times 20, all divided by 7 what? 50. Let's multiply 700 by 20. We are going to have 14,000, all divided by 750. You are going to have 18.6667 centimeter cube. And that's the answer for that, for question number 1. A gas has a volume of 546 centimeter cube. Volume V1 is 546 centimeter cube at 0 degrees Celsius. That's T1. 0 degrees Celsius. But mind you, this is degrees Celsius. Let's take it to Kelvin. Plus 273, which is going to be 273 in Kelvin now. What is the volume? V2 we are looking for. A volume of the gas at minus 100 degrees Celsius. T2 is minus 100 degrees Celsius plus 273. If we remove 100 from 2, that is 173 Kelvin. Then we are looking for V2. But if you look at that question, we are told that at constant pressure, that's Charles' law. Okay? So, at Charles' law, we are told that the volume is directly proportional to the what? Temperature. So that volume, for Charles' law, we have the volume is directly proportional to temperature. Okay? So which is equal to KT. So that V over T is equal to K. So that from there you can have V1, T1, V2, T2. So let's use this formula now. For V1, 546, and for T1, 273. Then for V2, that's what we are looking for. For T2, we are going to have 173 cross multiply. So that V2 times 273 will be equal to 543 times 173. 546. Sorry, this is 6. 546. Now what we are having? 546. Okay? 173. Then V2 will be equal to 546 times 173 divided by 273. So that V2 will be equal to, we have 546 multiplied by 173. We are going to have 94.458 divided by 273. We are going to have 346 centimeter cube. Question number 3 says, the pressure of air in a tire is 22.5 Newton per meter squared. That's P1. Hertz. That's T1. 27 degrees Celsius. That's plus 273. And now we give you another value for your temperature. Plus 273. Let's leave it like that for now. Let's look at the remaining parameters. If the air in the tire heats up to 47 degrees, that's our T2. T2, which is 47 degrees Celsius, 47 degrees Celsius plus 273 to convert it to Kelvin. Calculate the new pressure, that's P2 of the air, assuming that no air leaks out and that the change in volume of the air can be neglected. This is a prior law. This is a prior law. And if you remember prior law, the prior law states that for a fixed mass of gas is directly proportional to the absolute temperature, provided the volume remains constant. The volume remains constant. And for volume to remain constant, the pressure is directly proportional to the temperature. Let's look at this. Pressure directly proportional to temperature. Pressure, that's KT, that's P, over T is equal to K. So from here we can have P1, T1, P2, T2. That's what I'm going to use. Let's look at the value of this. We are having 27 plus 273, and we are going to have the 300 Kelvin. Then what about 47 plus 273? We are going to have 320 Kelvin. Let's substitute all this value into this equation. P1, that's 22.5. T1 is 300 is equal to P2. That's what we are looking for.